Hi everyone, happy Wednesday. I hope you've had lovely holidays. I'm sorry that obviously we're not having a normal lesson today. As you know, you're coming in later to get tested, and so this is a quick remote lesson for you to do this morning. So you still feel like you're getting a lesson, but obviously we can't do the same things that we would do in person. So as I explained on Google Classroom, if we were together, we would be going through your assessments. We obviously won't because it just doesn't work remotely, but what does work is doing a normal lesson. I actually see you tomorrow for a normal lesson, so like in person, as it were. So we'll go through your assessments tomorrow, so you don't have to wait very long. But instead, today, we are going to finish your GCSE course. Oh my gosh! This is your last teaching lesson. So, by the time you see this video, I'm hoping you've already gone to Caboodle and you have done the interactive resource titled Centre of the Earth on page 239. And that should just remind you about what we did just before Christmas. We talked about the layers of the Earth. We watched a wonderful song, if you remember, which was about the inner core, outer core, mantle and crust. And so, as I say, I hope you've done that resource. And we're going to look today at how we actually know what's inside the Earth. So I just told you what was inside the Earth last time, and now I'm going to talk to you about how we know that. So I've given the title today, Inside the Earth. It's not the 30th of November today. It is, in fact, the 5th of January, and it's 2022 today. So if you can title and date, that would be fabulous. And if you just pause this video at various points to take notes, that would be really handy. The diagram that comes a couple of slides on, I have put on Google Classroom if you need it from there. So, how do we know what is inside the Earth? We know because there are such a thing as earthquakes. Now, earthquakes are effectively kind of earth-shuddering events that produce types of waves. They produce two types of waves, both of which can be classed as seismic. Seismic waves are produced by earthquakes. And we can detect those waves using seismometers. And by looking at what type of wave is detected at different places in the Earth, we can figure out what the Earth is made of. So the two types of wave that you need to know about are P waves and S waves. And you need to know the difference of them, about them, differences between them. They're the words. I'm so rusty. I haven't taught obviously since December. Sorry. Differences between them, and we're going to look at that on the next slide. So, on this slide, you can see I have written a table and a couple of questions. And I'm going to get you in a moment to pause this video, go to page 244 and 245 of the Caboodle book, and you're going to use those pages to answer these questions. I will obviously go through the information in a moment, but I'm hoping that by the time I've gone through the answer, you've already had a little look and you've read the textbook page to get that information yourself. So if you can please pause the video now, answer those questions, and then we'll go through the answers. Okay, hoping everyone's had a chance to pause. Let's go through answers, shall we? So, full name. P waves are actually called primary waves. And they are called primary waves because they arrive first, which also answers the question underneath. Are they faster or slower? They are the faster of the waves. So, primary, and they are faster. Now let's do S waves. S waves are secondary waves because they arrive second. We do try and be fairly logical in physics. And as a result, their speed is slower. Now, P waves are longitudinal, and S waves are transverse. Now, the way I remember is that I turn an S on its side, and it looks like a transverse wave. So S waves are transverse. Now, do they travel through the Earth? Yes. P waves, longitudinal waves, do travel through the Earth. No, S waves do not. So P waves do, S waves do not. Do they travel through solid and or liquid? P waves can travel through both. They can travel through solid and they can travel through liquid. However, an S wave can travel through a solid, cannot travel through a liquid. So a P wave can travel through both, an S wave can only travel through solids. They cannot travel through liquids. Now, underneath, I have put a question, which is a revision question. As you know, P5 is all about waves. And we've talked about P waves and S waves being longitudinal or transverse, but you obviously need to know the difference. So the official definition of a transverse wave is a wave where the particles vibrate at right angles to the direction of energy transfer. So if you imagine it like a water wave, the particles are going up and down, but the energy is being transferred forward. So it's like a Mexican wave, if you remember in class, where you all put your arms up and your arms are going up and down, but the energy is going side to side. A longitudinal wave is where the vibrations of the particles or oscillations are parallel to the direction of energy transfer. So this is, imagine you were all in a line and you all had your arms on each other's shoulders and you're all facing the front, for example, and you all put your arms on each other's shoulders, and then I shoved the person at the end of the line and they shoved into each person in a row, passing the energy along. Now in that instance, your vibration will be going side to side and the energy will be going to the side. So they are parallel. Now the next question, what are shadow zones, is best explained on the next slide. So if we have a look, now this diagram, as I say, is on Google Classroom, so please feel free to just print it from there, that's absolutely fine. If I see you tomorrow, when I see you tomorrow, if you need the diagram, let me know and I can print some off for people, not an issue. But shadow zones are basically the zones where the types of waves are not detected. So you know we talked about those seismometers picking up the seismic waves. Shadow zones are where those seismometers cannot pick up any waves. Now if you have a look at the diagram, you can see that there are shadow zones for P waves. Now I said P waves can travel through the Earth, but there are still shadow zones, and that is because P waves, like other types of waves, are refracted. Now cast your mind back to P5. Refraction means the changing of direction of a wave when it enters a new medium. And if you can have a little look at that diagram, can you see those P waves actually bend? And as a result, because of that refraction, that changing in direction, there is an area where actually you don't pick up any P waves because they just don't bend that way, as it were. So there are shadow zones for P waves, but S waves have a much larger shadow zone, and that is because we know that the centre of the Earth is liquid, and S waves, being transverse, cannot travel through a liquid, which means they cannot get through that centre of the Earth. So basically what they can do is they can look at which types of waves are detected at different places, and it's that information that told us that we have an inner core, outer core, mantle and crust, and that they're all made up of slightly different things. And that's it. Course done. GCSE. Tick. I mean, nearly. So, Posh Poppers all around. Next thing you're doing, once you've watched this video, is you are going to do a summary sheet. I've popped it on Google Classroom, and I will be popping the answers up later on as well. All right, thanks everyone. Please let me know if you have any questions on Google Classroom. If you'd like to Zoom me, just let me know and I'll send you a code, that's fine. I will be available during our lesson, so that is 10 to 11. No, 10 past 10. 10 past 10 to 11. That's our lesson times, isn't it? 10 past 10 to 11. Yes, so just let me know if you need any help. Google Classroom, as I say, and I will see you all tomorrow. Goodbye, goodbye, goodbye.